C program for generation of Fibonacci numbers using recursion. Here Fibonacci numbers are 0, 1, 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8. You see here Fibonacci numbers, you see here like this. Here for example, if I take 1 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13. Okay, 0th Fibonacci number is 1, 1 Fibonacci number is 1, 2 Fibonacci number is 2, 3 Fibonacci number is 3, 4th Fibonacci number is 5, 5 Fibonacci number is 8. Okay, this is a sequence of Fibonacci numbers. We have to give two numbers. Here I have given for recursion. This recursion will be implemented for a few programs, for limited programs. Okay, for this program here I have given 1 and 1, 1, 1. Two numbers we have to give 1 and 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 3, 5 plus 8, 13, like that. Okay, you see here for this program, you see here this is the program for Fibonacci using recursion. Recursion is a function is called by itself. Okay, you see here. This is the Fibonacci program. First, we take variables num, res, enter the number. We read the number through keyboard. Next, function call. After calling the function, we have to, this is the call function, calling function, declaration of a function. Okay, so this is the invoking a function. Okay, function will be represented with left and right parenthesis. Here semicolon is the declaration of a function or invoking a function. Here this num is the actual parameter. Okay, here this is the call function. Okay, this num is the actual parameter. Whenever we call this function, we will go to called function. Okay, you see here, whenever we call, this call function should be there in the main function. Actual execution will begin from main only. Whenever we call, then immediately we will go to called function. Okay, we will go to called function. Then from the called function, next once again we will come to here. Next from here once again it will be called. Here this a function is called by itself. A function, you see here, name is the fib. This fib is called by itself, is called a recursion. After that, next same function, fib only, argument n minus 2, it's called by itself. This is the recursion. This is the recursion. A function is called by itself, is called recursion. Okay, here we have two subfunctions. In this subfunction we have two. First, this will be called by itself. Next, second time, this function will be called by itself. This function will be called by itself. Okay, this is the recursion concept. Repetition of a function, that is, a function is called by itself. We enter a number. For example, if I enter a number 3, that 3 will read through keyboard and we keep that in a particular address in the memory. After that we will call a function, then we will enter into called function, then we will enter into called function. Okay, Here that argument, here I have given 3, that 3 we pass into call function. Whenever we pass, that value will be copied into called function. This is the call by value. Okay, for example, if I pass here address, the concerned value will be passed here. That is the call by reference. But here I passed value. That value will be copied here. This is the original parameter, original argument, actual parameter or actual argument. Okay, here instead of num we can take n. This n is the formal parameter, dummy parameter. The value will be received from num to n. Here I have given 3, that 3 will be copied here. Okay, copied here. Next, is 3 equal to 0? Is 3 is 1? This is the OR operator. Either of one should be true. Then the entire condition will be true. At least one should be true. Then total will be true. This is the if condition. So here 3 is not 0, 3 is not 1. So this statement will not be executed. We will go to else. Return fib. Here whenever we call a function, the value will be pushed into stack in the main memory. Whenever we return, the value will pop. Push means insert into the stack. Pop means taking out from the stack. Okay, whenever we call, we push the value. Whenever we pop, we take out from the stack. Okay, so here we pass 3, that value is copied. 3 is not 0, 3 is not 1. So we will come to return fib of, you see here our function name is fib 3 minus 1. Fib of 3 minus 1 is 2. So that 2 will be copied to here. Okay, next 2 is not 0, 2 is not 1. So we will go to else part. Okay, 2 minus 1, 1. For this here I will explain. You see here, first 3 I copied from call function to called function. This is the called function or defined function or invoked function or definition of a function. This is the body of the function. Our function name is fib. Okay, 3 not 0, 3 not 1. So fib of 3 minus 1. What is the 3 minus 1? Fib of 2. Next, fib of 3 minus 2. Fib of 3 minus 2 means fib of 1. So this 2 we pass once again. This function is called by itself. This is the fib of 2. This is called by from here. Fib of 2 is passed here. 2 is not 0, 2 is not 1. So we will come to here. Okay, you see here, whenever we pass 2, once again 2 values are there. That is fib of 2 minus 1. That is fib of 2 minus 1 is fib of 1. Fib of 2 minus 2, that is fib of 0. Okay, so now we call this function by itself. That means this one we will go to here. What is the fib of 1? Here 1 will be passed here. 1 is 0, no, false. 1 is equal to 1, true. At least 1 should be true, then only it's true. Total condition in OR. In AND condition, if 2 should be true, 2 expressions should be true, then only total will be true. But in OR condition, at least 1 should be true. But here 1 is not 0, but 1 is equal to 1, true. So total condition true. So return 1. Return 1 means we take out from the stack. Earlier when we called, we push, now we pop from the stack. Okay, now we return 1. You see here for fib 1 we return 1. We will get the answer. Next, second function, this one, fib of 0, this one. Okay, this we will pass. A function is called by itself, is called recursion. Okay, here 0, what is that? Fib of 0. That 0 will be passed here. 0 is 0, yes, true. 0 is 1, false. true or false? True. Okay, so we return 1. For this fib of 0 we return 1. Next, what's the remain? The fib of 1 is remained, so we call this function by itself. So fib of 1, last one, that is fib of 1, we pass 1. 1 is 0, false. 1 is 1, true. False or true? True. Return 1. For this fib of 1 we return 1. Total, we will add that values. What is the fib of 1 value? 1. What is the fib of 0? 1. Here operator is plus. Here operator is plus. So this value is 1. This value is 1. This value is 1. This value is 1. Before this preceded by plus. Before this preceded by plus. Okay, 1 plus 1 plus 1, 3. The n, for the n of 3, answer is 3. Okay, this is the generation of Fibonacci numbers in recursion. For example, if I give 4, okay, if I want to find for the number of 4, for the number of 4, Fibonacci number is, you see here, n is 0, 1. For n is 1, 1. If n is 2, 2. If n is 3, 3. If n is 4, 5. For the 4, 5. Now we found for the 3. For the n is 3, the answer is 3. You see here how we got. While we are calling, we push into the stack. While we are returning, whenever we return, the value will be popped from the stack. Okay, like this we will get the recursion for the Fibonacci number. You see here, generation of Fibonacci numbers. You see here, about the main, we write the prototype of a function or signature of a function. The purpose of writing is we instruct to the compiler regarding the usage of this function. Unless we instruct to compiler, we will get prototype error. To overcome prototype error, we write here prototype of a function. What we write here, just as it is, we will write. Okay, here what we write, the as it is, int fib of int n, as it is we write here about the main, the prototype or signature of a function. Either we can write here int, or we can write either int or int n. What is the variable received? The n is received, so we write here n. The num value is received by n, so we write here n. Or we can, it is need not to write n also, no problem. Just here we have to mention what return type, what's the function name. Here type is int, function name is fib. This is the user defined function. We have two types of functions, user defined function and standard functions. Printf, scanf, getC, putC, getchar, putchar, gets, puts, fscanf, fprintf, power function, absolute function, sign. All these are standard functions, but this is the user defined function. We can write our own name, that is the user defined function. You can write Fibonacci, fib1, any name. Okay, so here this is the user defined function. We can give our own name. User can define their own names for the functions. Okay, a function is represented with left and right parenthesis. Okay, if we put semicolon, this is the call function. In called function, we won't put here semicolon. If we put semicolon here at the end of this, control will not enter into this subfunction. Okay, this is the subprogram. Okay, this is called a function or method or procedure or unit. Okay, the advantage of the function, we can reuse the code, reusability of the code. That is the advantage of the function. Once you write as many as times, you can reutilize the function. Okay, Each function performs a specific task. You see here, this is the Fibonacci numbers, generation of Fibonacci numbers using recursion. Okay, here void means doesn't return any value. Here actual execution will begin from main. We have to declare the variables, enter a number, call the function, pass the value, then value will be copied into here, then we check, then the function is called by itself here. Okay, the function is called by itself. A function is called by itself here, that is the recursion. Okay, so we can find the Fibonacci value for the n number. Like this, recursion will be there, function is called by itself. This is the procedure. Okay, now we are going to compile and execute a program. Okay, now we got 0 errors and 0 warnings. If I give 3, enter a number, you see here, I here enter, number is 3. For this, my answer is, for the n of 3, Fibonacci number is 3. Okay, for example, if I give 4, you see here, if I give 4, here I have given 4. For the 4 Fibonacci number of 4 is 5. Okay, you see here, how we generate the Fibonacci numbers according to our requirement. Here I have given 1 and 1, 1 plus 1 2, 1 plus 2 3, 2 plus 3 5. For the n of 3 is Fibonacci is 3. For the n of 4 is 5. For that purpose, okay, here we use this recursion. Okay, in this we have to give 2 values. Okay, here I have given here, you see here, 2 values, n is 0 and n is 1. For n is 0 we return 1, for n is 1 also we return 1. Okay, you see here. If you like it, please share and subscribe. Thank you.